Well, good evening. In this lesson, we're going to talk about test lights. There's a variety of different test lights that are out there, and a whole family of them. And we want to look at navigating through the maze of different test light technologies, what's best for your application, make sure it's safe, yet give you good diagnostic information. It's kind of one of the overlooked foot soldiers in the diagnostic realm. And so what we want to do tonight is I'm going to give a series of demonstrations on different test light platforms so you have a good understanding of how they work, why they work, and what you should use them for. So the first one we're going to talk about here is the style with an incandescent bulb. So we got a traditional test light here, and I'll go ahead and we'll get her lit up. So it simply displays a regular incandescent bulb on there. It's going to draw a certain amount of current, so we got to think about that for what application it's going to be best at. Well, my experience with this style is going to be for lighting circuits or a heavier current load environment. And that's where they should be kept. So when we think about each application we're going to get into, so the conventional, you might have an old one from 50 years ago, or a brand new one you just bought off one of the trucks or bought online. But remember, if it has an incandescent bulb, it is going to pull more current. So let's go ahead and demonstrate. So what I'm doing now is I'm simply taking the hot side, my 12 volt source in this case, and going to the ground, and I'm going to go over to this relay. So we got just a conventional relay, and I just simply touch on there, and you can see that there's enough current flowing through this test light to bias, in other words, to control the relay. Well, it makes a great testing tool. Well, there's nothing wrong with that. But remember, if we were involved with any low current devices, any digital devices that are on the vehicle, and remember, we can go back a long time and look back really to the late 70s on up. So a test light like this has caused a few problems over the years because the amount of current that could be applied to a digital circuit could be in excess of what that circuit's designed. So again, let's go ahead and we'll just illustrate how much current it's going to take. So I've got a simple amp meter set up. It's in milliamps because I'm not expecting a lot of current. So I'm going to do is hook my positive up to the positive side of the meter. And then respectively, I'm going to take my test light ground and my 12 volt ground, hook them together. And then I'm going to take my ground to the meter, my negative terminal, so I'm completely on the ground side. So we're seeing here $49 milliamps. 49 milliamps is an unacceptable amount of current to be flowing into a digital circuit. On the flip side, this test light is phenomenal for doing controls and making sure a circuit is loaded. Remember, there's a whole different side to this. We can have literally a circuit broken and have some carbon on it, some oil on it, some salt. Any of that will show us, often the low impedance meters and test lights will give you a signal even though it couldn't pull any current. So one of the big advantages of this is actually you could feel a lot more confident when you check your wiring that you're actually pulling some current through the circuit. So you can see the test that we performed here. So from the top, incandescent bulb. Everybody look carefully at that. Good visibility, especially underneath the dash. I really like these. I've used them for, I hate to tell you how many years. They work very good, but they have their place. Remember to utilize them. If it's a high current device or you want to check integrity of a wire, they can actually pull some current. At least, we'll say rounded off 50 milliamps. So it's at least enough current to say we got some viability to the circuit. So the next one we're going to go on to is going to be our LED style. So let me grab that. And this is going to be a little bit different. What this one is going to do is actually going to rely on the plus and minus of the battery. So one of the goals is to try to get, when you hook up, as practical as can be, get as close to the battery, if not on the battery. Battery's preferable. So now I've done is I've hooked up my cigarette lighter adapter, or you could be using a one on the vehicle, but that's one of the downsides. We don't know if that's live or not, so that's one of the challenges. Okay, we see we have two LEDs lit up. We got a green and a red. Green for negative, red for positive. So I'm just going to go over here and I'm going to go on to the plus side of the circuit. So that's cut at the red light illuminates. Now let's go on to the ground side and we see that the green light illuminates. Just that simple. But these are a lot safer to use. They're a low impedance, so they can be used. Always be careful with your design, make sure that it can go down. But the safety factor, not guaranteed, but the safety factor is much better with going in and checking digital circuits. So again, using the right tool for the right job. And one advantage here is having the ground plane. So we got one base hookup to the test light, to the cigarette lighter adapter, and then we have the ability to see both positive and negative. This is incredibly handy when you're searching through wiring and you're probing in and trying to determine, is it a ground side or a hot side? Or is it the control side? I mean, so it will appear to be a ground side if it's going through a relay or such. Again, really helpful. You're again the right tool for the right job, so choose it wisely for what you decide to utilize. Now the next one we're going to use in our little arsenal here is the one that are going to be an LED but also have a meter display in it. In this particular case, I have two to choose from. So the two different designs we have, one is, and since experience here working on heavy duty equipment on our farm, I've actually utilized this 24 volts. So this one is designed to work up to 24 volts. So utilized on a relatively regular basis. And the other one is designed to work up to 12 volts. Now grant you they'll run a little bit higher than that without concern, but that's the range that it's intended to, so thresholds and so on the meter and the LED. So let's go ahead and hook this up. So the first one we're going to run here is our 12 volt. Go over here and we'll hook up, and we can see we have two things. We have a red light illuminating, and we have 13.9 volts displayed. So we have the best of both worlds. So if you can't see the meter display in it, you got the light for feedback. Let's go ahead and let's hook up with reverse polarity. Running the reverse polarity, we have a green LED displayed, and we show a negative voltage. So we achieve both. We have good data. We have our green LED indicating we're on a ground circuit. So I supplied power. Example, go into a fuse box, something of that nature, and you want to find out that you're onto a good ground and at the available current, say it's a current flowing ground circuit. This is a good example where you could go in, have something energized, and while it's energized, you'd be able to not only see that it's a ground, but you see if you have any voltage drop. But we'll go over here, and it will, all it does is illuminate it illuminates that we're on, that this is looking for a ground at this point. It's based on a ground circuit. So here's our ground, and if I'd feed power into it, it would energize the relay. But instead, it's just simply seeing the ground part of the circuit. Okay, that is our 6 and our 12 volt. Now our 24 volt will work similar to that. Again, we're seeing a display. It has no problem working within. So we got our 13.9. We have the red illumination telling us that we have positive power at the tip. Now this one comes with a red, I guess we'd say, we call it a ground, but we won't call it ground. This is simply our other side of our circuit. So we can either go like I had it to the negative, or we'll go to the positive. Just like the other one, we have a green LED and the voltage is displayed. This one is kind of well thought out using the red, but I know that is a confusing thing that we get to. Well, where should I hook it up? Depending on what you test. Plenty safe to hook this up to the negative side or the positive side. It depends on it. So the light won't care which way you hook it up. So again, we're checking, looking for a ground. Little bit of voltage drop simply because that light is operating here. I had 13.9, I have 13.7, so 0.2 of a volt is simply being used up in the electrical circuit, and a little bit of current that's going through. It just simply pulls just that little bit of current, and it's consumed the voltage in my wiring and through the relay windings. Okay, so them are the two things that are critical. That this one, remember, it can be both negative or positive side of the battery to get your baseline ground. This one, so you don't confuse yourself, that one is the same way, except they're utilizing a red hookup. Okay, the next one is going to be a cord-free style. It's a little different animal. It has its purpose. Like every tool, has its place. Now, grant you, this is just a voltage indicator. That's all it's intended to do, is to tell us that we have voltage available. Well, obviously, we're on the ground side of the circuit. I'm becoming to earth ground because there's a carbon rod on here, a carbon path, I should say, a carbon path, and as long as you're holding on to it, and you're not sitting in a dry desert where you might need a little bit of moisture, it works really good. It's got an audible tone in this particular case, and it simply tells me I have voltage available. So as I would go through the circuit here, but I want you to take note, all that means that it's a live circuit. You can see it's trying there a little bit, and the reason it's trying is I have a transformer. So there's a transformer inside this box that produces that voltage. And because it's still running a little bit of voltage out of it, so it is a great product, but it can fool you. Now, if I had the battery physically disconnected, I have it turned off here, but there is some transient voltage going on. So it's a good tool, but be aware that it's not going to be one that is going to be a high-end diagnostic. It's a quick, do we have a circuit? Is the circuit completed? And that's the extent of what I would use the tool for. But again, not to make light of it, it actually has a good purpose, and it does get utilized. It's something that I use in quick reference when I'm underneath the dash, trying to figure out what we got going on. Sometimes it's the first one, I don't have to hook anything up. I can just simply go and check, hey, do we have power available? Every test light has its purpose. So we just went through our little continuity tester. Great for its particular application. We talked in depth about the incandescent style, the higher current draw. And make sure that you're utilizing this correctly so it's intended for higher current load environment. But it also has a real benefit. In that particular case, you can simply put it on there, and if you had that transient voltage that you'd see in a meter, this won't display it. It will not be there, will not illuminate the light bulb because it's too much current. So it's one of the things to keep in mind. One of the things to keep in mind. So that tool has a real good value. So if you got an old one or just bought a new one, use it in the right application. These are much more designed. These are more designed to work in that more digital world. Again, we got to be cautious when we get around computer circuits down to the logic level. And remember, kind of the newer they are, and if we're looking at data links, anything that's got a twisted pair on it, anything of that nature, then we got to just make sure that we're all the way back into the ultra high impedance meters that are certified for that environment. Again, I wouldn't hesitate to use it, but have a level of caution as you go through and utilize each tool. We have other tools that are better equipped for when you're in a digital world, but if we're any kind of control circuit, these style are great because you have the LED and you have the display both. And remember, looking at using both hot and ground side of the circuit. It's a really quick way to move through a troubleshooting environment. Well, I hope you learned something in this session. Make sure you subscribe. Comment if you have any thoughts on other videos that I could put together. And I thank you so much.